Hi, everybody. Welcome back. So just to go back a little bit in the section 11-3, slope of a line, rate of change, rise over run. So you notice that the slope measures the steepness of a line. There's the slope formula. And I'm using the instructor notes, so sometimes it can be a little bit off the way that it looks. But you have some positive slope, you have negative slope, zero slope, and undefined slope. So make sure that you are clear about what that looks like. And here you have some ways that slope is calculated using the graph, showing you the steepness, the rise over run, and the actual calculation of slope. And as you can see, you have some sample problems. So parallel and perpendicular lines, right? So just read that over. The slopes matter. So parallel lines have the same slope. Perpendicular lines have the opposite reciprocal. So that means that if I have 3 as the slope, the negative reciprocal would be negative 1/3. Okay? So that is what you have to think about. And then you have some forms of how we can display slope. So we have the standard form of an equation of a line. We have slope intercept form. And then there's also point slope form. So just check out those forms of slope, what they mean, what kind of slopes you have. I know that there's a little, it almost looks like a typo, but you can just use your book. Your book matches all of the notes and the PowerPoints. And then graphing a line using its slope and y-intercept. And then you can see what that looks like. So you usually have to plot a point, and then you can use the slope to find another point. And then as you can see here, there are more examples. And then we move on to writing an equation of a line. So writing an equation in slope intercept form, you have to be given a slope and then a point, and then you substitute those points in, and then you figure out what the equation of a line is. Those points, well, whatever point they give you is going to actually be on that line. And then some concepts into the last section before your exam, right? You have these concepts. Now, I'm just showing you what it looks like in the PowerPoint, but these concepts are also going to be in your book. So you need to read them over, and this is the actual application of linear functions. So when you look at these points, you are going to use this example to start to think about and estimate the wait time based on that equation, and you're going to plug in the month and figure it out. Okay, you're going to figure out, you can actually use the line to figure it out. So if you look here, it looks like the wait time at 1 month is about 5.6. So for this section, 11.6, applications of linear equations and modeling, again, just use your book. It has really nice graphics, examples. These do match the PowerPoint, so if they look familiar from your PowerPoints, that's why. Okay, so remember that when we are talking about linear functions, we are talking about things that usually happen over time. So notice the kind of slope that you have, right? It's a negative 0.8. And then notice the trend line, right? So the line is telling you and giving you information about what is happening. So the months are on the x-axis and the time is on the y-axis. And then you're going to use the equation to estimate the wait time in month 1. So all you do is you substitute 1 in for x, right? And you can kind of see it here on the graph at month 1. The wait time is between probably 5.5, 5.6 minutes. Okay. And then you can see here what happens when you substitute the numbers in, then you get an exact value. Okay, you're not solving for X, you're solving for Y. So just keep that in mind and then just go over all of those solutions. And then you have some skill practice. So you can plug those numbers in, right? The cost Y in dollars for a local move by a small moving company is given by Y equals 60X plus 100, where X is the number of hours required for the move. How much would be charged for a move that requires 3 hours? Remember, Y is in dollars, so X has to be hours. And it also says it in the sentence, in the directions. So just guesstimating, right? 3 times 6 is 18. So add a 0, I have 180. 180 plus 100 would be 280. And then you can click on and see your answers. So just use your book accordingly. Go over all of the examples. Remember, I did all of the examples in all of my math courses in the book. I read the book. That is the best way to prepare yourself for the best understanding, I think. So I'm not going to go over all of these because you have these in your Alex program. But I'll just show you what they look like. And then writing a linear model, given a fixed value and a rate of change. Okay, so you're going to figure out what the linear model would be, and then you're going to figure out whatever it's asking. And in this case, it's asking for cost in dollars. So you have to use the information to figure it out. Okay, and then there's an activity that you can go over, and then of course there are some practice exercises. Okay, and for your last section in the homework 21.1, we're talking about distance formula, midpoint formula, and circles. So you went over some square root problems. You did Pythagorean theorem, and then you start to move into other things that are close to geometry, trigonometry, and actual engineering problems. So you can read over those. If you're in Pennsylvania, if you remember 3 Mile Island, we have those kinds of things here. And then we have the distance formula, circles, writing an equation of a circle. So the distance formula is going to be similar to the Pythagorean theorem. Okay? So just read this through. Do the example. Be careful of your signs. Be careful because distance is positive. So we do not do the negative value when it comes to, so if we get any negatives, you know that it doesn't make sense. Okay? Finding the distance between 2 points, okay, is why we use the distance formula. And you can probably gather the real life application of that. And then circles. So all circles have a fixed point in each circle, right? And it is the center. And then from the center out to any part of that circle is the radius. Okay? So the equation of the circle reads as x minus h squared plus y minus k squared equals r squared. Okay? If a circle is centered at the origin 0, 0, then h is equal to 0, k is equal to 0, and the equation simplifies to x squared plus y squared equals r squared. I'm going to show you an example of x squared plus y squared equals r squared. Okay. I'm just going to, I wanted to zoom in. Let's zoom in. Okay, and so you can see here that the radius is 1. You see all the way around the circle, it's 1, right? And you see it over here, right? So if I turn that radius on now, it's blue, but I'm just going to leave it. And then I'm going to show you what happens when I make the radius bigger. And we don't really, there's no point in going negative because it means the same thing. It's pretty much the absolute value because R is not negative, okay? So you can see what that looks like, all right? Now, if I turn that off, I can say y is equal to the square root of, which, remember R was 1 minus x squared. And look at that, that's half a circle. Now, if I duplicate that and put a minus in front of it, let me go over here and put a minus in front of it. Now I have the bottom half of the circle. Isn't that pretty cool? So what I just showed you was a tool. And you can practice using that tool, and that's the Desmos graphing calculator. It's free, it's online. And you can actually graph this and see how it looks up close and personal. Okay? So just use the examples, read through, read the book. Okay? And then if you are given this equation, right? How can you figure out what that actual equation of the circle is? Okay? And so you're going to do something called completing the square. So you pretty much, if you look at the directions on the right side, if you look at the explanation on the right here, it says group the x terms and the y terms, move the constant to the right hand side. Okay, so that's the negative 61. And then you take half of the middle term. For the x's, it's 2x. And for the y's, it's negative 16. Okay. Sorry, if I said 2x, it's 2. So we take half of 2. And then for the y's, we take half of 16. And it is technically negative, but, you know, you have to square it. So it ends up being positive. And then that is how you end up with x plus 1 squared plus y minus 8 squared equals 4. Okay, so just be careful, follow those examples, and then you can do the review. Okay, writing an equation of a circle, you pretty much are filling in the blanks. Okay, so you are finding the center, and all that happened was there was a shift, right, of the circle left and right, and a shift of the circle up or down. So just be careful of that. Then the midpoint formula. The midpoint formula will explain the middle of any line segment. Okay, so it says the midpoint of the line segment between the 2 points is given by x1 or x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. And that's how you figure out the midpoint of a line. Okay, segment, right? Line segment. Okay, so just practice that. And that is the end of your last homework before your next test. So remember to practice. And as always, thank you for watching. See you next time.